This is a Python simulation of Bertrand Box Paradox problem. So we have imported this library called NumPy, and we are going to conduct 100,000 simulations, 100,000 tossing of coins. We are going to simulate 3 boxes using this list, 0, 1, and 2, and the content of 3 boxes are going to vary. So here are the contents of the boxes, with 1 representing gold and 0 representing silver. So box 0 has both golds, box 1 has got 1 silver, 1 gold, and box 2 has got both silvers. I will also keep track of the gold coins. So the first variable I'm going to initialize is that when the first draw happens, whether it turns out to be a gold or not. So we're going to keep track of that part through this counter. And once we have, in the first draw, have received a gold coin, then the second coin, does it result in a gold? That is tracked through this counter. So this is conditioned on the first counter. Only if the first draw results in a gold, then only we proceed and check whether the second gold has been the outcome of the draw. So the simulation is going to be like this. We are going to loop over the number of trials, 100,000 trials. There's a pre-given condition that the first coin has to be a gold coin. So I'm going to initialize a variable called first outcome, which must be a gold coin, and then this is how the conditional probability is set up in the simulation. So now we are going to randomly select one of the boxes. It can be anything. It can be 0, 1, and 2. We know that 2 does not contain any gold coins. It cannot. So no gold coin can come from box number 2. So we have to check whether what box we have chosen, whether it's box 0 or box 1. So that condition is checked here. So gold coin can come only from box 0 or 1, and this condition checks whether the selected box is 0 or box 1. And now we draw the first coin from either of these boxes. So if the box 0 was selected, we check what is the outcome of this box in the first draw. And if the box 0 was not selected, box 1 was selected, then we also check the outcome of this draw. Remember, we are sampling from the sample space of box 1 and box 0. This is 1 silver, 1 gold, and this is both golds. In fact, this will always result in 1. This line of code has been written just for redundancy. And once we have checked the outcome, if the first draw results in gold, which is the precondition set here, if the outcome of any of these boxes results in gold, then we are going to increment the first gold counter. So that's how we're going to keep track of the gold coins in the first draw. Then moving on to the second draw, once the first gold has been accomplished, then we are going to go for the second draw. And this, we know one thing for sure, that if the first draw is a gold coin, then box 1 has already run out of gold coins. It had only 1. The next coin is going to be a silver one. So the second gold coin can never come from box 1. And given that the first draw is gold, the only spare gold coin that is left is in box 0. So box 0 will always give gold coin in the second draw. So accordingly, I'm checking if the selected box is box 0. If it is, then I'm going to increment the second gold counter conditioned on the first gold that has already been received. Thereafter, I'm going to print out the probabilities. Probabilities are very simple. Total number of gold which were drawn in the first draw by total number of trials. This will give me the probability of drawing the gold for the first time. And once the gold has been drawn for the first time, what is the probability of drawing the second gold is calculated here. This is the content of the second counter conditioned on the content of the first counter. So this is how it's going to implement the conditional probability. Let's run and see how this works. So it's running the simulation. It's going to take some time. So probability of drawing a gold coin in the first draw is 50%, and it's quite natural because there are 3 gold coins and 3 silver coins, and that's how it's going to result in 50%. But more surprisingly is that once the first draw has resulted in gold coin, the second gold coin has a probability of 0.669, which is very counterintuitive because most of the people think that it's going to be 50%. We can also check the probability of first gold coin by this formula. So we have 1/3 probability of picking up any box. And then in that, we have to see what is the probability of getting the gold coin. So in the box 1, we have 100% guarantee because there are 2 gold coins. In box 2, we have only 1 out of 2 as gold coins, so half. And in the last box, we don't have any gold coins, so 0 probability of getting gold. So when we combine all this thing together, we get 50% probability of drawing gold in the first draw, which is what is shown here. And thereafter, when we have achieved this outcome, the second draw will result in gold with 66.9% probability. So that's what is the paradox all about.